Mhm. Hey guys, good evening, and welcome back again to your Unacademy NEET English channel. I hope all of you are doing great, having a good time. So, people, let me know in the chats if all of you can hear me, if I am perfectly audible, visible to every one of you. Let me know quickly in the chats, everyone. Let me know quickly in the chats with some fire emojis if all of you can hear me, if I'm perfectly audible, visible to everyone. Yeah? Good evening, guys. Good evening and welcome back. Good evening and welcome back. Good evening and welcome back. So tell me first of all, are you guys done with the yesterday's marathon? Are you guys done with the yesterday's marathon? Yeah, I just want to know that first. Say yes or no in the chats. Say yes or no in the chats quickly. Are you guys done with the yesterday's marathon? Yeah? Your class 11th Inorganic Chemistry? All right. All right. All right. All right. Got it. Got it. So, my dear students, today we are going to do almost like 300 questions from your class 11th Inorganic. Okay, from your class 11th Inorganic. And since you know in inorganic chemistry there is no calculation required, right? The questions will be always direct. So technically you guys are going to solve the questions on your own, and you will be letting me know the answers in the chats continuously. The chats should run continuously in the today's session. The chats should continuously run in the today's session. Okay? Yeah? Class duration will be like 2.5 hours, 3 hours. I don't know exactly. Let's see how long it's going to take. Okay? Perfect. At the same time, at the end of the session, I'll be sharing the handwritten PDF with all of you of the today's session. Okay? And PDF I'll be sharing on my Telegram channel. And I believe you all are already the part of the Telegram channel. If you are not the part of the Telegram channel, join the Telegram channel as soon as possible. The name of the channel is Wassim But Chemistry Official. WASSIMBHAT Chemistry Official is the name of the Telegram channel on which I keep on sharing all the stuff with all of you, right? So the ones who are not the part of the Telegram channel yet, be the part of the Telegram channel as soon as possible. Okay? Now, since you know, before starting the session, my question to you, what is that question? What is that question? Which part of the country you guys are watching me from right now? Which part of the country you guys are watching me right now from? I just want to know that first. See, I'm right now live from Srinagar, Jammu and Kashmir, right? And now I want to see from where you guys are watching me right now. I just want to know that first. All right, I can see majority is from South India, Tamil Nadu, Andhra Pradesh, Kashmir, Hyderabad, Karnataka, Kerala, AP, Vizag, Bengal, Hyderabad, Odisha. Nice. And Kashmir again, Manipur, AP, TN, Tamil Nadu, Telangana, Nasik. Okay. Bangalore, Kashmir, okay, perfect. Got it. Got it, guys. So let's get going then. Let's get started with the today's session, right? As I told you, basically, you are going to solve the questions in the today's session, okay? I'll be just standing here, giving you the questions. You'll be letting me know the answer of each and every question in the chats. So the chat should continuously run. Keep your chats open and be active with your laptop, phone from where you are watching me, right? And keep on writing the answers, whether right or wrong in the chats. Doesn't matter. If it is wrong, I'll correct it. If it's right, that's great. Okay? Hello, guys. Let's move on then. Let's get going. Let's get going. My dear students, the first question which is on your screen. Look at the question and read the question carefully. The IUPAC symbol for the element whose atomic number is 119. The IUPAC name of the element whose atomic number is 119. Tell me the answer of this particular question. Everyone. Everyone, people. What do you think is going to be the answer of this particular question? I want to see whether majority is going to give the correct answer or not. Guys, be careful. Do not hurry. Be careful. Be careful. Okay. The atomic number is 119, people, right? The atomic number is 119. Atomic number is 119. 1 means un. This one also means un. This 9 means ENN. And at the end, it's going to be IUM. Correct? This is the name. Now, what is going to be the symbol? Un starts with U. This un starts with U. This N starts with E. So it's going to be U, U, E. This is going to be the symbol. Perfect? U, U, E is going to be the symbol. So it's not going to be option 3. It's going to be option 2, my dear students. Right? So correct yourself in this particular question. It was simple, but I know a lot of students, when they see this sort of the question, they get that adrenaline rush, you call it. Correct? They feel like it's an easy question and they mark this one, UUN. Correct? But I don't want you to do that mistake. It's UUE. Okay? So be careful with that. All right, moving on to the second question, people. Moving on to the second question. Tell me the answer of this particular question. The element with atomic number 114 has been discovered recently. Okay, got it? It will belong to which of the following family, group, and electronic configuration? What do you think? Atomic number 114. Atomic number 114. Tell me. Let me see whether you actually remember things or not. Let me exactly see whether you remember things or not. 114, guys. 114. Atomic number 114. I hope you remember. I hope you remember. The last 2 digits here, that's 14. It's going to be the group number. It's going to be the group number. Group number 14. 14th group. 14th group means carbon family. 14th group means carbon family. And over here, there is only one option mentioned, which says carbon family. So it's option number 1. As simple as that. Right? Well, I can see majority has given the correct answer. That's amazing. Wonderful. Moving on to the next question. What do you think about this particular one? An atom has electronic configuration 1s2, 2s2, 2p6, 3s2, 3p6, 3d3, 4s2. Okay. Got it. You will place it in which group? You will place it in which group? Yesterday, I have discussed all of this in detail. You'll place it in which group? Quickly. I want the chats to be running. You will place it in which group? My dear students, 4s2, 3d3. 4 is 2, 3d3. Take the sum of n s electrons and n minus 1 d electrons. So 3 plus 2 makes it 5, right? So the element belongs to the fifth group, basically. Yesterday we have discussed in detail, right? In the yesterday's marathon, we have discussed in detail. I've told you how to check the group numbers, etc., etc. Okay? It is basically your D block element, right? It's basically your D block element, and for your D block elements, how do you check the group number? Ns electrons plus n minus 1 d electrons. That's all. So the element belongs to fifth group. Tell me the answer of this one. The element with atomic number 18. Not 18, sorry, 118. Element with atomic number 118. Everyone in the chats. Element with atomic number 118. So what is going to be the group number? Last two digits, that's 18. Group number 18 means noble gas. So the element is going to be noble gas. Right? Perfect. Moving on to the next one. Tell me the answer of this question. Again, this is the sort of the question which we discussed yesterday also. What do you think? The correct order of atomic radius of group 13. Group 13, right? Boron, aluminium, gallium, indium, and thallium. Down the group, what happens to the atomic radius? Atomic radius increases. Atomic radius increases. We know that. We have discussed that. But I hope you remember, there was one variation. What was that? What was the variation? I just want to know. There was one variation, guys, if you remember. Before this gallium, there will be D block elements. So technically from aluminium to gallium, size should increase. From aluminium to gallium, size should increase. But what happens? Before gallium, there are D block elements. And in the D block elements, the last electron enters into D subshell, right? And your D subshell, your D orbitals, they show poor shielding. Due to poor shielding, effective nuclear charge is more. Size decreases, right? Size decreases. So the size of gallium would be less than that of aluminium. Size of gallium would be, see, down the group size increases, but the size of gallium would be less than that of aluminium, right? So the option is option 3. This is the correct answer. We have discussed this in detail in the yesterday's session. I hope you remember. All right. Kill it. Everyone. 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 You are given with some isoelectronic species, you have to arrange them on the basis of their size, or you can say ionic radii. Right? Yesterday we have discussed, if you talk about the size or ionic radius, that is directly proportional or inversely. I just want to know. Simple. More the positive charge, more the effective nuclear charge. More the effective nuclear charge, lesser is going to be the size. Right? Lesser is going to be the size. So which one is going to have the maximum size or minimum size? Tell me. It's Al tri positive that will have the minimum size among all. So this is the order. No exception. No exception. We have discussed it. Size is inversely proportional to Z effective. More the effective nuclear charge, lesser the size. And your Z effective, we have discussed yesterday. Z effective is directly proportional to positive charge, inversely proportional to negative charge. Correct? So more the positive charge, more Z effective means lesser the size. Simple. Simple question. Moving on to the next one. Tell me the answer of this particular one. Among the following elements, calcium, magnesium, phosphorus, and chlorine, the order of increasing atomic radii. The order of increasing atomic radius. Tell me. Quickly. Quickly, guys. Well, you know chlorine. Chlorine is your group 17 element. Phosphorus is your group 15 element. Magnesium is group 2nd. And calcium is also group 2nd. When you move from left to right in the periodic table, size decreases. Size decreases, right? Size decreases. So group 2 elements will have more size than that of these two. Now, among magnesium and calcium, calcium, down the group, size increases. So calcium will have more size than that of magnesium. So calcium will have maximum size, followed by magnesium. Is there any option suggesting that? Yes, option C. So option C is the correct answer. Yes? Perfectly done. Tell me the answer of this particular question again. You have to give the answer as per size. More the positive charge, lesser the size. More the negative charge, more the size. Simple. So what is the answer? More the negative charge, more the size. More the positive charge, lesser the size. So what is the order of the size here? What is the order of the size here? S di negative will have maximum size, right? And Ca di positive will have the minimum size. Ca di positive will have the minimum size. Okay. So what is going to be the order? Quickly in the chats. Quickly in the chats. Quickly in the chats. Absolutely, it's going to be option 1. That is going to be the correct one. Yeah? Everyone is right. Amazing. Good, guys. Good. I like it. Okay. This is something, again, which we have discussed yesterday. So you should be, again, in a position to answer this one as well. We are given with the second period elements. We have to talk about the increasing order of ionization energy. Well, first of all, you know, when we move from left to right, what happens to ionization energy? Ionization energy increases, right? So if I talk about lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, what should be the expected order of ionization energy? This should be the expected order. But yesterday I have told you have to interchange few things. Beryllium comes here, boron comes here, right? Among nitrogen and oxygen, nitrogen comes here, oxygen comes here. That is the order. Again, we have discussed this. Right? Perfect. So it's going to be option 2. That will be the correct answer. This is something which was discussed in detail in the yesterday's session. Yeah? All right, people. Tell me the answer of this one. The first ionization potential among the following elements: beryllium, boron, carbon, nitrogen, oxygen. Again, the similar question. See, if you compare just two elements, oxygen and nitrogen, nitrogen has got more ionization energy than that of oxygen. Why? Because here you have got half-filled configuration, which is more stable. So to take electron out from that configuration, you have to supply more energy. So directly, without wasting a lot of time, I'll directly go for option 1. I don't have to check the rest of the things. I won't be comparing all the other things. Only one option is suggesting me that nitrogen has got more ionization energy than that of oxygen. I'll go with that. That's it. I'll go with that. Okay. Tell me the answer of this particular question. Well, these are the elements of your group 16. Oxygen, sulfur, Se, Te. And there is PO as well. Leave that aside. They have not given that in the option. So give me the order of the electron gain enthalpy. If you talk about electron gain enthalpy, guys, you know, down the group, electron gain enthalpy decreases. Right? So I would say oxygen should have maximum, then comes sulfur, then comes Se, then comes Te. This is the expected order of electron gain enthalpy. But we have discussed in the yesterday's session. Among oxygen and sulfur, if you compare oxygen and sulfur has got more electron gain enthalpy than that of oxygen. Why? Because of the smaller size of this oxygen. Dude, that is the reason why oxygen comes at the end of the order. Because of the smaller size of oxygen, it comes at the end of this particular order. So this is the electron gain enthalpy order. Okay? Yesterday, I just compared oxygen and sulfur, and we saw sulfur has more electron gain enthalpy than that of oxygen. Why? Because oxygen has got smaller size, more charge density, right? Okay, due to that, I would say oxygen has lesser electron gain enthalpy than that of sulfur, right? But if you compare it in the overall group, right, it will have least among all. These. Okay, so it is going to be option 1. Right? Now, if I move on to the next one, what about this one? Which one of the following arrangements represent the correct order of least negative to most negative electron gain enthalpy? Least negative to most negative electron gain enthalpy. Tell me. Tell me. Tell me, guys, quickly. Least negative to more negative. Quick, people. If you look carefully, this is your group 17 element. This is group 16, right? 14, 13, group second. When you move from left to right in the periodic table, electron gain enthalpy increases, right? So electron gain enthalpy becomes more negative on moving from left to right. On moving from left to right, electron gain enthalpy becomes more negative, right? So fluorine will have maximum followed by oxygen. So this is the correct answer. This is the correct answer. Okay. Let me move on to the next one. Tell me the answer of this one. Tell me the answer of this one. Which of the following options, in which of the following options the order of arrangement does not agree with the variation of property indicated against it? Does not. Okay, they mentioned the term does not. Now tell me the answer. Tell me the answer, guys. See, the first option is absolutely correct. If you talk about the ionic size, right? More the negative charge, more the size. More the positive charge, lesser the size. So this is the correct order. If you look at the next one, increasing first ionization energy. We know nitrogen has got more ionization energy than that of oxygen. If I talk about the first ionization energy, right? So this is incorrectly given. So I was supposed to check that only. So it's option 2. That has to be the correct answer. Yes. It's absolutely option 2, guys. Amazing. What do you think is going to be the answer of this question? You have to arrange them again from less negative to more negative. Less negative to more negative. Now, first of all, this is your group 17. This is your group 17. This is also group 17. This is group 16. This is group 16. So you have got oxygen, you have got sulfur, you have got fluorine, you have got chlorine. You have to arrange them on the basis of their electron gain enthalpy. Now, since you know, group 17 elements have got more electron gain enthalpy than that of group 16. You know that already, right? Now, among fluorine and chlorine, chlorine has got more, then comes fluorine, right? Among oxygen and sulfur, sulfur has got more, then comes oxygen. What is going to be the order then? I would say option 2 is going to be the order. Option 2 is the correct one, right? Amazing. Moving on to the next one. This is something which I told you in the yesterday session. I gave you one table at the end, if you remember. I gave you one table at the end, guys. I told you that particular table was important, wherein I had given the acidic oxides, neutral oxides, amphoteric oxides, basic oxides. Now tell me the answer of this question. Tell me the answer of this question. Quickly, you can only solve this question if you remember that table which I gave you in the yesterday session. Yeah? Quick. Think over it. Think over it. My dear students, Na2O. Na2O. Na2O is basic. It's a basic oxide. Al2O3. It is an amphoteric oxide. N2O is neutral one. Cl2O is going to be what? Cl2O7 It's going to be acidic oxide, right? Now you can check the options. 1 with B, 1 with B, 1 with B, okay? 2 with D, 2 with A, 2 with D. It's option A. That's the correct one among all. Okay? Chalo, moving on to one more. Look at this question. What do you think? What do you think about this one? What do you think about this one, guys? Quickly. Outermost electronic configuration of group 13 element. Group 13 element. Group 13 element E. Okay, is 4s2 4p1. All right, 4s2 4p1. The electronic configuration of the element of P block, period 5, placed diagonally to the element E. Tell me the answer of this question. Quickly. See, if you talk about group 13 element, boron, aluminium, gallium, indium, helium, right? Now, boron's outermost configuration is, this is 2s2, 2p1. This, if you remember, 3s2, 3p1. This used to be 4s2, 4p1. 5s2, 5p1. Correct? So, they are talking about the element E, whose electronic configuration is 4s2, 4p1. Now, which one has got 4s2, 4p1? It's gallium, which has got 4s2, 4p1, right? So, this is your element E. Now, you have to check which element is diagonally connected to this. So, talk about your group 14 element. Carbon, silicon, germanium, tin, lead. So, which is diagonally related to this? It is tin. Carbon has the outermost configuration of 2s2, 2p2. This will have 3s2, 3p2. This will have 4s2, 4p2. This will have 5s2, 5p2. Right? So, it's going to be outermost configuration of the element which is diagonally related to this is going to be 5s2, 5p2. Do you have any option like that? 5s2, 5p2. Done? Option D. Okay? Option D is the correct answer. I hope you got to know how to solve this question. All right, moving on to one more. This is something which you can easily solve. Tell me the answer of this question, guys. Let me sit for some time. Tell me the answer of this question. Tell me the answer of this particular question. Ionic radii of K positive, Na positive, Al tri positive, Mg di positive. So tell me, Al tri positive will have least size, more the positive charge, least the size, lesser the size. More the positive charge, lesser the size, right? Perfect. So Al tri positive will have least size. Then comes Mg di positive. Now among K positive and Na positive, K positive, they are in the same group. Down the group size increases. So K positive will have more size than that of Na positive. K positive will have more size than that of Na positive. So it's option A. That's going to be the correct one. Okay? That's going to be the correct one. Moving on to the next one. Tell me the answer of this one. Let me check your options, what you're saying. Check this one out, guys. Check this one out quickly. The set of elements that differ in mutual relationship from those of other sets. Okay. Quick. Think logically, guys. Think logically. Use your brain a bit. Use your brain a bit. Now you have started giving correct answer. If you talk about your lithium and magnesium, so for example, lithium, sodium, potassium, rubidium, cesium, beryllium, magnesium, calcium, strontium, lithium, magnesium, they are diagonally related. Similarly, when you check boron and silicon, they'll be also diagonally related. When you check beryllium and aluminium will come here, right? This is boron, this is aluminium. This is gallium, right? So these two are also diagonally related. Diagonally related. So lithium and sodium, are they diagonally related? No. Lithium and sodium is not diagonally related. So it's going to be option D, right? Which is going to be the correct answer of this particular question. Moving on to the next one. Tell me the answer of this one. In general, the property that shows an opposite trend. The property that shows an opposite trend in comparison to other properties across the period. See, across the period, electronegativity increases. Across the period, electron gain enthalpy increases. Across the period, ionization energy also increases. Across the period, size decreases, radius decreases. So this is going to be the correct one. This is the odd one out. Odd one out, people, right? So you don't have to think a lot in this question. It's already solved. Tell me the answer of this one. Now use your brain properly and solve. Don't think it's easy question and then you are going to make some silly mistakes in this. Don't do that. Avoid that. Nil, un. Option D. Yeah. Someone is saying all the questions have option D. Is that? Okay, tell me this one. I think this is a repeated question, right? We solved it in the beginning. 119. Ununium. UUE. I know there will be a lot of students who will be again answering this UUN, right? In the rush. What about this one? What about this one, guys? Quick. The element with atomic number 120. 120 means you will place it where? Where would you place it? See, if you talk about your 118th element, that's going to be the noble gas, group 18, right? 119th element will come again in group 1, right? 120th element will come in group 2. Group 2 is what you call as alkaline earth metal. Yes. 118 is your noble gas. 119 will again come in group 1 and 120 is going to come in group 2, your alkaline earth metal. Tell me the answer of this one. The group number, the number of valence electrons and the valency of the element with atomic number 15. Well, we directly know which element this is. We directly know which element this is. We directly know which element this is. Atomic number 15. Which one? Atomic number 15. 2, 8, 5. 5 electrons in the valence shell. Right? 5 electrons in the valence shell. Nitrogen family. Nitrogen family. Right? So the element has to be phosphorus. After nitrogen is going to be phosphorus. Now phosphorus, if you talk about its group number, phosphorus belongs to 15th group, number 1. Second, number of valence electrons. Number of valence electrons is phosphorus are 5. Valency is going to be 3, right? So 15, 5, 3 is going to be the correct answer. Right? What about this one? The element having greatest difference between its first and second ionization energy. Think about it. Think about it quick. First and second ionization energy difference will be maximum in. Quick. Think over it. Guys, think logically. Why you are writing the wrong answers? Now people have started giving the correct answer. Good. It's going to be potassium, of course, right? It's going to be potassium. Potassium has got 1 electron in its outermost shell. Potassium belongs to group 1. Group 1 has got 1 electron in its outermost shell. So take the first electron out, right? Now, the second electron you have to take from completely filled configuration. So you have to supply a lot of energy. So the difference between first and second ionization energy in potassium will be maximum. Yeah? I hope this is clear. I hope this is clear. Okay, next. In general, the properties that decrease and increase down the group. Down the group, electronegativity decreases. Down the group, atomic radius increases, right? Down the group, electronegativity decreases. Electron gain enthalpy decreases. Electron gain enthalpy decreases. Electronegativity decreases. Atomic radius increases. Electronegativity decreases. So we have to check in general the properties that decrease and increase. Decrease and increase is the first option. Option A. Perfect. Tell me the answer of this one. Ionic radius of N3 negative, O di negative, F negative are respectively. See, more the negative charge, more the size. So N3 negative will have maximum size, right? Then comes your O di negative. Then comes your F negative. This is the order of the size, right? This is the order of the size. So N tri negative will have maximum radius, maximum ionic radius, maximum is 1.71. Then comes O di negative, right? So it's going to be this one. Then comes the least one, 1.36. So it's option C. That is the correct one. You just have to check the values. That's it. Nothing more, nothing less. Okay. I think this question we solved in the yesterday session too. This particular one we solved in the yesterday session too. The first ionization potential of sodium is 5.1. First ionization potential of sodium. So you're taking 1 electron out from sodium. When you take 1 electron out from sodium, how much energy is required? 5.1 volts. So delta H here is 5.1 volt. 5.1 electron volt. The value of electron gain enthalpy of Na positive. Electron gain enthalpy means you have got Na positive gas. You are giving it 1 electron. It will get converted into Na gas. So can we say this particular process is reverse of this? If it is a reverse of this, so change the value of delta H. So delta H here will be minus 5.1 electron volt. This is what I call as ionization energy of Na. This is what I call as electron gain enthalpy of Na positive. Okay. So it's minus 5.1. Both are reverse of each other. We have discussed this in very depth yesterday. Tell me, which of the following represents the correct increasing first ionization energy? Okay, increasing first ionization energy. This is your group 18, this is group 16, this is group 2, this is group 16, this is group 2. So first of all, we have to talk about the increasing ionization energy. First of all, group 18 means your noble gas. Noble gas have got complete octet. They have got the most stable configuration. Most stable configuration means to take electron out from there, from them, you need to supply a lot of energy. So argon will have maximum. Argon will have maximum. After argon, you are going to prioritize which one? On moving from left to right in the period table, ionization energy increases. So group 16 will have more. Now group 16, this is group 16 and this is group 16. Now amongst S and SC, which one will have more ionization energy? Quick. Among S and SE. Among S and SE, they are from the same group, right? Down the group, ionization energy decreases. So sulfur will have more. Sulfur will have more. So it's option C. That is matching with all of this. Identify the least stable ion. Identify the least stable ion. You have got many ways to solve this question. You can talk in terms of bond order. You can talk in terms of bond order. Or you can say just one thing. If you talk about beryllium, atomic number 4, 1s2, 2s2. Completely filled, right? So, is it going to be ready to take 1 electron? It won't be ready to take 1 electron because it has got already stable configuration. The most unstable is going to be Be negative. Or you can talk in terms of bond order. Lesser the bond order, Lesser the bond order, lesser the bond order, lesser the stability. Okay. Tell me this one. This is pretty much simple. The set representing the correct order of first ionization potential, first ionization energy. First ionization energy. The set represents correct first ionization energy. Down the group, ionization energy decreases. Okay. Down the group, ionization energy decreases. So beryllium, magnesium, calcium, beryllium, magnesium, calcium. Down the group, ionization energy decreases, right? So beryllium will have maximum, followed by magnesium, followed by calcium. I hope this is clear. Which of the following has got maximum number of unpaired electrons? Maximum number of unpaired electrons. Okay. If I talk about iron, what is the outermost configuration of iron? It is 3d6 4s2. Now it's basically iron di positive. So take 2 electrons out, which will be taken out from here. So it's 3d6 4s0. 3d6 means 1, 2, 3, 4, 5, and 6. So how many unpaired electrons do you see? 4 unpaired electrons. Right? Titanium. If you talk about titanium, scandium titanium, it's 3d2 4s2. But it is titanium tripositive. Take 3 electrons out. 2 from here, 1 from here. 2 from here and 1 from here. It becomes 3d1. So there is only 1 unpaired electron. Mg di positive, no unpaired electron. Scandium titanium vanadium. Vanadium is going to be 3d3, 4s2. It is vanadium tripositive. Take 3 electrons out. 2 from here, 1 from here. When you take 2 from here, 1 from here, it will have 2 unpaired electrons. So where do you see maximum unpaired electrons? Fe tripositive. Yes. Fe tripositive. Fe dipositive, sorry. Yes, Fe dipositive. Okay. Tell me the answer of this one. Among us the elements whose electronic configuration is given, the one having the highest ionization energy. Highest ionization energy. See, over here 3p3 configuration, half filled. 4p3 configuration, half filled. Half filled configuration, right? To take electron out from them, more energy is required, right? Now this is, you have to take electron from third shell. Here you have to take electron from fourth shell. Third shell means closer to nucleus. Closer to nucleus means you have to supply more energy, right? So this will have more ionization energy. Got it? Again, a simple question. The first ionization potential of sodium, magnesium, aluminum, silicon. Sodium, magnesium, aluminum, silicon. The first ionization energy order. Tell me the order. Let me sit for a minute. Check it out. Check it out, guys, quick. Check it out quickly. Sodium, magnesium, aluminum, silicon. Same period. Along the period, ionization energy increases. But there will be a variation. What variation is it going to be? What variation it's going to be? Now, if you talk about sodium, you have got magnesium, you have got aluminium, you have got silicon, right? Okay. Along the period, what should happen? Ionization energy should increase. It should increase. It should increase. So this should be the order. This should be the order. Perfect. This should be the order. But is it the actual order? It's not the actual order. Actual order will be like this. Sodium, magnesium. Magnesium is greater than that of aluminium. Right? Because in case of magnesium, you have to take electron out from 3s2 configuration. 3s2 means this is 3s2. In case of aluminium, you have to take electron out from 3p1 configuration. 3p1 configuration. Here you have to supply more energy because of more penetration power, or you can say completely filled configuration. Okay, so it's going to be option A. That will be the correct answer of this particular question. Hydration energy of Mg dye positive is greater than. Hydration energy of Mg dye positive is greater than. You know hydration energy? That is directly proportional to charge, inversely proportional to size. Hydration energy of Mg dye positive is larger than that of Na positive. Because its charge is less, so its hydration energy will be less. Right? The electron gain enthalpy order. Fluorine, chlorine, bromine, iodine. Definitely, chlorine will have more ionization, more electron gain enthalpy than that of fluorine. Chlorine will have more than that of fluorine. Right? So this is the option. Chlorine has more than that of fluorine. So option C. Okay. Guys, that's why we say inorganic is definitely easy as compared to your physical and organic, right? Okay. Because it does not take a lot of time to solve the questions. The absolute value of electron gain enthalpy. Chlorine has got more than that of fluorine. Chlorine has got more than that of fluorine. Few minutes back only I told you. Not few minutes back, few seconds back. What about this one? If the ionic radius of Na positive is 1.02 angstrom, the ionic radius of Mg dye positive and Al tri positive will be. Okay. See, Na positive. Then you have got Mg dye positive. Then you have got Al tri positive. Right? So more the positive charge, lesser the size. If its radius is 1.02 angstrom, right? Al tri positive should have least. Al tri positive should have least. So Mg dye positive and Al tri positive. Al tri positive should have least. Al tri positive should have least. So Mg dye positive will be comparatively more than that. Right? This is the option suggesting all of this. Okay. So it's option 2, which is the correct one. Tell me the answer of this one. Tell me the answer of this one. The correct order of radius. More the negative charge, more the negative charge, more the size. More the negative charge, more the size. So option 2. No need to check the rest. This is the repeated question, I think. The IUPAC symbol for the element with atomic number 119. Yes, it's a repeated question, so leaving it aside. I think this is also repeated, is it? No, this is not repeated. You have to answer this one. You need to answer this one. You need to answer this one. Quick. What's the answer of this one? N3 negative will have maximum, followed by O negative, followed by F negative. So it should be the decreasing order. Decreasing order of this one, option C. Imagine if this sort of a question comes in your exam, how lucky you are going to be. Yeah? The force of attraction that holds various constituents together in a molecule is what you call as chemical bond. Cation and anion combines in a crystal to form the ionic bond. When a metal atom combines with non-metal atom, the non-metal atom, what happens to that? Metal atom loses electrons, non-metal atom gains electron. And when non-metal atom gains electron, it gets converted into anion. And the size of anion is more than that of the parent atom, right? So it gains electron and increase in size. Gains electron and increase in size. Yeah? Gains electron and increase in size. Which of the following does not represent the correct Lewis structures? When you show the Lewis structure, you have to show the valence electrons. Carbon has got 4 valence electrons, so you have shown 4 valence electrons. Oxygen has got 6 valence electrons, you have only shown 5 here, so this is incorrect. Neon has got 8 valence electrons, you have only shown 6, incorrect. Beryllium has got 2 valence electrons, you have shown 2. Boron has got 3 valence electrons, you have shown this. Carbon has 4 electrons, you have shown. So second and third are incorrect. Second and third are incorrect, so it's option D. Yes? Pajan's rules. Covalent bond is favored by smaller cation and larger anion. Smaller cation and larger anion. Smaller cation and larger anion. Yeah? Polarizability order. Polarizability of anions. Polarizability is directly proportional to charge of the anion as well as directly proportional to size of the anion. More the size of the anion, more the polarizability. So I negative has got maximum size, so I negative will have maximum polarizability. Yes? LiCl, BeCl2, BCl3, CCl4. Covalent character order. The charge on lithium here is +1, beryllium +2, boron +3, and carbon +4. More the charge on the cation, more the polarizing power, more the covalent character. So CCl4 will have maximum covalent character. CCl4 will have maximum covalent character, followed by BCl3, BCl2, LiCl. Option C. Simple. Maximum covalent character is shown by, this is Al tri-positive here, this is Mg di-positive, this is Cs positive, this is Sn di-positive. More the positive charge on the cation, more the polarizing power, more the covalent character. Yes? What is the correct order of decreasing ionic character? Decreasing ionic character means increasing covalent character. So we have to give the order of increasing covalent character. Increasing covalent character. Now if you look carefully, this is Cl negative, this is F negative, this is I negative, this is Br negative. Perfect. The size of I negative is maximum, so it will have maximum covalent character. Maximum covalent character, right? After that comes your Br negative, then comes Cl negative, then comes F negative. This is the increasing order of covalent character, or you can say this is the decreasing order of the ionic character. Okay, this is the increasing order of covalent character. What I was supposed to give? I was supposed to give the decreasing order of ionic character. So 3 will have, 3 is maximum covalent, or you can say least ionic. 3 is least ionic. 3 is least ionic. So it's option 4, right? 3 is least ionic, option 4. Select the most ionic and most covalent. First one should be most ionic, second one should be most covalent. First one should be most ionic, second one should be most covalent. See, chromium here will be in +6 oxidation state, manganese will be in +7 oxidation state, lead here in +2, this manganese +7. I think this is the answer. See, more the charge on the cation, more is the polarizing power, more the covalent character. So this is more covalent. And this is less covalent. Less covalent means more ionic. This is more ionic, right? So more ionic, more covalent. So option B. Yes? I hope this is clear. All right. You give me the answer of this question. I'm just sitting here. Give me the answer of this one. Arrange the following in increasing order of covalent character. NaCl, RbCl, MgCl2, AlCl3. AlCl3 will be maximum covalent because it is Al tri-positive. Then comes MgCl2 because it's Mg di-positive. Now among NaCl and RbCl, Na positive, Rb positive. Na positive has got less size, more polarizing power, more covalent character. So NaCl will be more covalent than RbCl. So what is the order? What is the order? What is the order? Quick. Quickly, people, in the chats. What is the order? Guys, you should be answering this question like in very lesser time. You should not take a lot of time to solve this because it's a simpler one. It is a simpler one. What is the order here? Absolutely, order is C. I think this question I showed you yesterday also. Which of the following set of molecules will have zero dipole moment? Zero dipole moment. See, BF3, zero dipole moment. BeF2, also zero dipole moment. Carbon dioxide, linear, zero dipole. 1,4-dichlorobenzene. So it's option C. This is shown in the yesterday session. It's the same question. And this question was asked in NEET as well, long back. Dipole moment order. More the electronegativity difference, more is the dipole moment. Electronegativity difference between oxygen and hydrogen is maximum, right? So water will have maximum dipole moment. Now, among NH3 and NF3, here the electronegativity difference between nitrogen and hydrogen is more than that of nitrogen fluorine. So this is the correct one. BF3 has zero dipole moment. You know it already. It will have least zero. The neutral molecule XF3 has zero dipole moment. The element X is likely to be XF3, zero dipole moment. So it's supposed to be BF3. Few minutes back on I told you. It's supposed to be BF3. So boron has to be element. All the bonds are placed at an angle of 120, right? Tell me, which of the following is polar? Which of the following is polar molecule? Quick. If you remember your AB2L0 till AB7L0. AB2L0, AB3L0, AB4, AB5 till AB7L0. Also AB2L3 and AB4L2. I told you yesterday these are the molecules which have got net dipole moment equal to 0. So they are non-polar. Apart from all these molecules, whatever molecule you see, that's going to be polar. If you talk about SF4, 4 sigma bonds, 1 lone pair. So it's AB4L1. If it's AB4L1, does not come in this category. So it's polar. Right? So it's polar. All this we have discussed in detail yesterday, guys. Which of the following possesses dipole moment? SF6 is of the type AB6L0. SO2 is of the type AB2L1. This is of the type AB2L2. SF4, AB4L1. Which of the following possesses dipole moment? See, AB6L0 does not possess the dipole moment. Okay? All the others, they possess the dipole moment. So B, C, D, they possess the dipole moment. They possess the dipole moment. Yes? Is it clear? Is it clear, people? All right. What about this one? Tell me its answer. Simple. What do you think about this one? PP overlapping will be shown by what? See, H2 molecule will show SS overlapping. HBr will show SP overlapping. HCl will show SP overlapping. Chlorine, p orbital, chlorine, p orbital. They will show PP overlapping. This also which we have discussed yesterday. The angle between the overlapping of 1s and 1p, 1s and 1p, head-on overlapping, right? 1s and 1p, head-on overlapping. So at an angle of 180. At an angle of 180, correct? Which of the following represents zero overlap? Same sign, same side. Same sign, same side, positive overlap. Opposite sign, same side, negative overlap. Over here, there is no overlap. There is no overlap. Zero overlap. Bond energy order. Bond order is directly proportional to bond energy. Bond order means number of bonds. So more the bonds, more the bond order, more the bond energy. The total number of pi bond electrons in the following structure. Pi bond electrons. They're not asking about the pi bonds. They're asking about the pi bond electrons. Right? So how many pi bonds do you see? 1, 2, 3, 4. 4 pi bonds means 8 pi electrons. Okay? Means 8 pi electrons. So in rush, a lot of students are going to option or are going to take this one as well. But that's not the correct one. This is going to be 4 pi. It's going to be 4 pi bonds. 4 pi bonds means 8 pi electrons. The molecule not having pi bond. Cl2 molecule, right? Cl2 single bond, oxygen there will be double bond, nitrogen there will be triple bond, carbon dioxide, this is the structure, right? So it's Cl2, in which there is no pi bond. Yes? Which of the following molecules represents the order of hybridization sp2, sp2, sp, sp? See, this carbon is forming 3 sigma bonds, means sp2. This carbon is also forming 3 sigma bonds, sp2. 2 sigma bonds, sp. 2 sigma bonds, sp. Right? In your sp3d2 hybridization or d2sp3, which d orbitals are involved? I have given you all this in the yesterday's session. It's going to be dz square and dx square minus y square. Dz square and dx square minus y square. These are the orbitals which are involved while mixing, while intermixing. I hope you remember. ASF5. ASF5. If you talk about the valence electrons of arsenic, that's 5. Sigma bonds, 5. Lone pairs, 0. Steric number 5 plus 0, 5. Hybridization sp3d. sp3d means S, px, py, pz and dz square. S, px, py, pz and dz square. This again something which we have discussed in the yesterday's session in detail. Talk about XCF4. XCF4. How many valence electrons with xenon? 8. How many surrounding atoms? 4. So 4 sigma bonds. How many lone pairs on xenon? Out of 8 valence electrons, 4 are used. So there are 4 left as such in the form of 2 lone pairs. So steric number is 4 plus 2, 6. Type of the molecule is AB4L2. Hybridization is going to be sp3d2. Right? AB4L2 is going to be square planar. AB4L2 is going to be square planar. Again, we have discussed this. It's option A. Yeah? Tell me the answer of this particular question. This is again simple only, not difficult. Tell me, people. Quick, quick, quick. Done? Done, people? The species having the bond angle of 120 is going to be BCl3, sp2 hybridized, bond angle of 120. HOH bond angle in water is 104 degree 5 minutes, not 109 degree 20 minutes. Why is that? Because of the lone pair repulsions in water. Because of the lone pair repulsions in water. Select the correct statement regarding shape of PCl5, BRF5 and IF7. See, if you talk about your PCl5 is of the type AB5L0, trigonal bipyramidal. BRF5 is of the type AB5L1, square pyramidal. Pyramidal. IF7 is of the type AB7L0, right? Pentagonal bipyramidal. Now, all are square pyramidal, no. All are trigonal bipyramidal, no. Out of the given compounds, one of the given compounds is square pyramidal. Yes, one is square pyramidal. This is correct. One of the given compounds is tetrahedral. No, there is no compound tetrahedral. Yes. There is no compound which is tetrahedral here. I believe all of this is clear. Right? Tell me the answer of this one. Among the following, which one is wrong? Which one is wrong? BH5, BiCl5 does not exist. That's correct. Is wrong. Huh? This is the correct statement. P pi D pi bonds are formed in SO2. Correct. SEF4. SEF4 is of the type AB4. AB4L1. CH4 is of the type AB4L0. So they do not have same shape. This is wrong. I3 positive as band geometry. This is correct. Again, this is something which we have discussed yesterday. So it's option C, that's incorrect. Right? Someone is saying, sir, please send the PDF not with a black background. I don't know how to convert this into white background first. I'm really sorry about that. I don't know how to convert this into white background. Okay? I'm technologically very unsound person. Which of the following molecules has more than one lone pair? SO2, sulfur has got one lone pair. XCF2, 1, 2, 3, 3 lone pairs. SiF4, no lone pair. Carbon, no lone pair. Maximum lone pair here is xenon. XEF2 is isostructural with. What is the type of this molecule? The type of this molecule is AB2L3. Now check which of the following has got the same type. If you talk about ICl2 negative, iodine valence electrons are 7, there is a negative charge, so add that, so 7 plus 1, 8. 2 surrounding atoms, so 2 sigma bonds. How many lone pairs? Out of 8, 2 are used, 6 are left as such in the form of 3 lone pairs. So type of the molecule is again AB2L3. So since this type and this type, they are same, so they are going to be isostructural. They are going to have same shape. Whenever you have to answer the question when it comes to isostructural compounds, you just have to check the molecules which have got same type. Molecules which have got same type, they will be isostructural. Which of the following is correct? SO3 dinegative. Is it tetrahedral? Nope. The type of this molecule is going to be AB3L1. AB3L1, when you check it out. NO2 negative is going to be AB2L1. AB2L1. ClO4 negative is going to be AB4L0. NH3 will be AB3L1. I hope first of all you know how to check the type. Right? I've taught you in detail in the yesterday session how to check the type. And if you just know how to check the type of the molecule, you can check everything. Yeah? So which of the following is correct? AB4L0 is tetrahedral. ClF3, the number of lone pairs on the central atom. ClF3. Chlorine, how many valence electrons? 7. Surrounding atoms, 3. So 3 sigma bonds. Out of 7, 3 are used. So 4 are left as such in the form of 2 lone pairs. Right? So there are 2 lone pairs on chlorine. Is this something which I was supposed to check? The number of lone pairs on central atom chlorine. Yes, there are 2 lone pairs on chlorine. Okay? Perfecto. Water has positive value of net dipole moment, whereas BeF2 has 0 dipole moment. Why is that? Because in case of B di positive, in case of BeF2, the structure is linear. The moments, they cancel each other, right? So BeF2 is linear and water is bent. That's the logic. That's the reason. Okay? That is the reason. Identify the wrongly matched. See, by just looking at the question, I got the answer. This is wrongly matched. ECl5 is AB5L0. AB5L0 is trigonal bipyramidal. Here they have mentioned trigonal planar. So this is wrongly matched. Rest all will be correct only. Rest all will be correct only. Hybridization of xenon in XeOF4. XeOF4. Xenon. How many valence electrons? 8. How many surrounding atoms? 5. How many lone pairs? See, it had 8 valence electrons, out of which 4, and this is divalent. 4 plus 2, 6 are used. So 1 electron pair is left here as such. So the type is AB5L1. Or you can say steric number is going to be 5 plus 1, 6. If steric number is 6, it's going to be sp3d2. Okay. Similar sort of question. Which pair of the compound is isoelectronic and isostructural? You just have to check the type. Wherever you see the type of the molecule same, that's going to be isostructural. Wherever you see the type of the molecule same, that's going to be isostructural. Okay, that's going to be isostructural. I hope this is clear. Okay. Match these compounds in the following. XeF4, it is AB4L2 type. AB4L2 means square planar, square planar, square planar. Where is that? So you have to match A with 2. You have to match A with 2. B is already matched with 3. Okay. C you have to check. C just now we checked, I think. That was, okay, let me check this C again. XeOF4. Xenon, how many valence electrons? 8. Surrounding atoms, 5. Lone pairs on xenon, 1. The type of the molecule, AB5L1. AB5L1 is square pyramidal. Is there any square pyramidal? Yes. So C with 4. C with 4. So it has to be option B. Guys, this much amount of time. The way I'm solving the question, you have to solve the question in the similar manner. NO2 negative, NO2 positive, NH4 positive. If I talk about NO2 negative, nitrogen, how many valence electrons? 5. There is a negative charge. Plus 1 makes it 6. How many surrounding atoms? 2. So sigma bonds 2. Out of 6, since oxygen is divalent. Out of 6, oxygen is divalent. 2 2s are 4. So out of 6, 4 are used. 2 are left as such in the form of a lone pair. Right? So steric number is 2 plus 1, 3. Hybridization is going to be sp2. Right? Talk about NO2 positive. NO2 positive. Nitrogen. 5 minus 1. Because there is a positive charge. 4. Sigma bonds. 2. Oxygen is divalent. 2 2s are 4. So all the 4 electrons are exhausted. Lone pair is 0. Steric number 2 plus 0, 2. Hybridization sp. NH4 positive. When you check it similarly, it's going to be sp3. Yeah? Okay. Which of the following structure is more stable? ClF3. If you talk about your ClF3 structure, this is ClF3. ClF3 has got T-shaped. It is T-shaped, right? It is AB3L2 type. AB3L2 type. So T-shaped is this one. If you hide these lone pair, it's going to be T-shaped, right? This is the structure of AB3L2. Perfect. That is your ClF3 here. XeOF4, how many angles are 90 degree? I'm giving you the answer 0, but you have to tell me its explanation in the chat, in the comment section afterwards. When the video ends, do tell me the explanation of this particular one in the comment section of the video. Okay, this I'm keeping to you. In case of XeOF4, right? It is AB5L1. It is square pyramidal. It is square pyramidal. Square pyramidal. But it is square pyramidal. But there is no bond angle which is 0. I mean, there is no bond angle which is 90 degree. Correct? Do tell me the logic of this question in the comment section. Which of the following species has same hybridization? This CH2 here, carbon is sp2 hybridized. This carbon is also sp2 hybridized. Why? Because both the carbons are forming 3 sigma bonds. Right? Now, among all these, where is the hybridization sp3? Sorry, sp2. Tell me, where is the hybridization sp2? If you talk about CO3 dinegative, CO3 dinegative, where is the hybridization sp2? Quick. If you talk about this CO3 dinegative, carbon, how many valence electrons? 4 plus 2, 6. Sigma bonds, 3. Oxygen is divalent, so 3 2s are 6. Lone pair, 0. So steric number is 3 plus 0, 3. If steric number is 3, hybridization is going to be sp2. Okay? Tell me this one. Quickly. Done with this? Which of the following is not expected to exist? So you have to calculate their bond orders. And any species which has got bond order less or equal to 0, that is non-viable, that does not exist. So when you check the bond orders, it's going to be Be2, right? If you write its molecular orbital configuration, it will have same bonding and anti-bonding electrons. So formula is half of number of electrons in bonding minus anti-bonding. So it will have 0 bond order. Again, this is something which is discussed already. Similar sort of question. Which of the following is paramagnetic? Paramagnetic. If you talk about O2, when I showed you yesterday the molecular orbital configuration of O2, in the molecular orbital configuration of O2, there were 2 unpaired electrons. In pi star, there were 2 unpaired electrons in pi star. Unpaired electrons means paramagnetic. So O2 is paramagnetic. O2 is paramagnetic. The total number of anti-bonding electrons present in O2 molecule. Again, if you write the molecular orbital configuration of O2, O2 has got 16 electrons. So 2, 4, 6, 8, 10, 12, 14, 15 and 16. Now check the anti-bonding electrons. 2, 4, 5 and 6. So in total there are 6 anti-bonding electrons in O2. Questions like these are also asked. Okay, when you convert O2 into O2 negative, definitely it will be gaining 1 electron. This 1 electron goes into which molecular orbital? That's my question. This 1 electron goes into which molecular orbital? If you see the molecular orbital configuration of O2, this is the molecular orbital configuration of O2. Here it is pi star 2px1, pi star 2py1. Now when you want to give 1 extra electron, that will go here. Pairing will happen. So it goes into pi star 2px. Okay? It goes into pi star 2px. Which of the following diatomic molecular species has only pi bonds? Yesterday I told you C2 molecule. 2 bond order 2 and both the bonds were pi bonds. Where do you see the bond order same? Isoelectronic species have same bond order. Cn negative and CO both are 14 electron species. Their bond order will be 3. Same bond order. Common feature among Cn negative, CO and NO positive. All of them will have 14 electron species. All of them are 14 electron species. So they are isoelectronic first of all. And isoelectronic species have same bond order. So there are 14 electron species. Their bond order will be 3. For the following ions, correct the bond order. Okay. 14 electron species, bond order 3. 15 electron species, bond order 2.5. 16 electron species, bond order 2. 17 electron species, bond order 1.5. 18 electron species, bond order 1. Similarly, 13 electron species, bond order 2.5. 12 electron species, bond order 2. 11 electron species, bond order 1.5. 10 electron species, bond order 1. Now O2 is 16 electron species. O2 negative means 17 electron species. O2 positive means 15 electron species, right? And O2 di-negative means 18 electron species. Perfect. Now arrange them on the basis of their bond orders. You can do it now. Easy. This question also we solved in the yesterday session. Bond dissociation energy order. Your bond order is directly proportional to bond dissociation energy, which is inversely proportional to bond length. I hope you know. Now, this is 14 electron species. It will have bond order of 3. This is 8 2s are 16 plus 1, 17 electron species, bond order of 1.5. This is 16 electron species, O2, bond order of 2. Now, more the bond order, more the bond dissociation energy. So N2 will have maximum, then comes O2 negative, then comes O2 negative, N2 will have maximum, then comes then comes O2, and then comes your O2 negative. There is no option like that, I think. First comes N2. First has to be N2, then has to be O2. Okay, this option 3. This is the correct order of bond dissociation energy. Option C. Yeah? This is again that I discussed yesterday. The relationship between the dissociation energy of N2 and N2 positive. If you talk about N2 and N2 positive, this is a 14 electron species. This is a 13 electron species. Its bond order is 3. Its bond order is 2.5. Right? More the bond order, more the bond dissociation energy. So N2 will have more bond dissociation energy. Dissociation energy of N2 will be more than that of N2 positive. So it's option C. Okay? Perfect. So guys, this was all about it. Right? These were the questions which I had come up with. But there are some questions which I'm keeping as a homework. You'll find these questions in the PDF. You'll find these questions in the PDF. But there might be some questions which are repeated, which I can see here. Okay? But do give them a try. And I believe you can easily solve all of these now. Okay? I believe you can easily solve all of these now. The PDF I'll be sharing in the Telegram. Okay? The PDF I'll be sharing in the Telegram channel. Wassim But Chemistry Official. Abdul, the color of this cannot be changed because these are the pre-made slides. I cannot change its color now. I cannot change its color now. That is the point. I hope you understand. All right, chalo, I'm taking a leave with this. I'll see you guys soon in coming days. Okay, we'll have more marathons. I'll keep you updated on my Telegram channel. Okay, chalo guys, do let me know in the comment section if you liked the session or not. I hope all the sessions, majority of the questions in this particular session you would have solved on your own if you would have attended the yesterday's marathon. Because if you have attended the yesterday's marathon, then I believe all these questions you would have easily done. Okay. Chalo. The remaining questions which I'm keeping in the PDF, do give them a try, right? And if you are not able to solve any sort of question among those questions, do let me know on my Telegram itself. Okay. See you guys. Take care. God bless.